Morning, everybody. It's a bit of a tale of engineering daring do, really, and we have to wind ourselves back to March of last year when there was a real crisis on. And I think you'll all remember the headlines in the newspapers, particularly with Italy, which was about 4 or 5 weeks ahead of us, starting to turn patients away from hospitals because they didn't have enough ventilator equipment. That caused UK government to take stock of what ventilators we had, and we only had 8,000 in the UK, and all the forecasts were predicting that we'd need around 30,000. So guess what happened next? Government tried to order some ventilators, of course couldn't find anywhere on the planet, nobody prepared to give them. So real panic ensued. And it resulted in government putting out a plea to industry in general for help. And the clinicians, the medical regulator, as well got together to develop a specification called the Rapidly Manufactured Ventilator System, the RMVS, which was a sort of a spec to say if you could make something that does this, airflows, pressures, etc., then we stand a chance of saving some people. So they issued this spec, and then there was this phone call between the Cabinet Office, headed up then by Michael Gove, and probably around 100 enthusiastic and willing industrialists on this Zoom call. And Gove introduced the ventilator spec in a typical sort of politician's way, and then said, right, over to you, industry, can you go and make it? And there was complete and utter silence on the phone, because on one hand, a well-intentioned specification to fix the problem, on the other hand, a bunch of willing industrialists to do something, but a huge gap in terms of actually making something happen. So at the time, I was running the high-value manufacturing catapult, and those who don't know what we do, we help companies scale up challenging technology. So it seemed like the right kind of thing for the catapult and me to step in and say, I think I can do something. So right at the end of the call, I volunteered to get some people together to see what we could do. So at that point, the pressure was on me to do something about it. So I then set up a consortium. So I started phoning people who I knew and trusted that were prepared to take something of a personal risk and put a program together. And so making a few calls, we got a group together, some of the big names there, the consortium signatories, Ford, Airbus, McLaren, Siemens, and these are people who I knew were prepared to take a personal punt on it, because at that point we were operating without any visibility of being paid for anything, so I needed a lot of goodwill behind me. So as a group we met, all engineers, all experienced in complicated program management, and said, right, how are we going to do it? And the response of the team was the quickest way of doing something would be to scale up some existing technology. We did know of other groups that set themselves up to have a go with a blank canvas, and you could kind of see why they'd start from scratch, because that meant they had unconstrained supply chains, could start from scratch and be in control of it. But we felt the quickest way was to get behind an existing device. There's only 2 people that make ventilators in the UK, Braze in Stratford-on-Avon and Smiths Industries in Luton, but both of them only make a paramedic device, so the kind of thing that you first response you'd have in the back of an ambulance, and it really wasn't suitable for this kind of long-term intubation which the forecast was telling us we need. So anyway, get on with do something. So we got behind Smiths and started to help them scale their production up. They typically make about 20 or 30 units a week, so we put a lot of muscle in behind Smiths to help them scale up. And in doing that, we established quite a degree of credibility as a consortium with the Cabinet Office, who were ultimately the customer of all of this. Although it wasn't the device that the clinicians and the regulator wanted, at least it was something. So having established credibility on the Monday and through that subsequent week, I took a call on the Friday from the Cabinet Office to say, we'd like you to have a look at a device which we think fits the bill. And I got given a guy's number in a very small company called Penlon in Abingdon. And Penlon make anesthesia equipment. And so I phoned the guy and said, I hear you might have something. He said, yes, we've configured some of our existing equipment to meet this spec. And the clinicians say, if you can make that, that's the one we want. So do you think you can help us? So I said, right, okay, this is the Friday night. I said, I'll send a team in tomorrow morning, and if we think we can make it, then be prepared, because we'll unleash an enormous amount of industrial horsepower. You need to be ready for it. So I kind of coached him about what was going to happen next. We sent a team in first thing on the Saturday morning, and they reported out to the consortium at 4 o'clock. It was basically, do you think we can make it? And we did a bit like a sort of Capcom in Saturn V, where we just had all of the consortium members. Are we in? Yes. Are we in? Yes, yes, yes. Cross the piece. And from that point on the Saturday the 20th, we were all in behind the Penlon device. So we had some fantastic resources at our disposal. It brought together the best of big industry with Ford and Airbus, with all of the kind of corporate muscle behind it. The nimble, fast-moving motorsport with Formula One, with McLaren, and the exacting standards of medical devices through Siemens and Siemens Healthineers. So that combination of that core, we started then building around that the rest of the consortium. So bringing in logistics, change management, a whole raft of additional resources from the Formula One teams, because at that time, of course, Formula One had been stood down completely. So we had the resources of all the UK-based teams. Imagine, guys, you're not doing anything at the moment. Do you fancy a challenge? You bet. So shed loads of top-quality engineering talent, and of course the machine shops of all of the Formula One teams. So what we're up against, not quite a car or a plane, but it wasn't a simple device. That's the Penlon ESO 2, about 700 part assemblies in each one. This was manufactured, the sort of sub-assemblies, bear in mind this didn't exist as a device, this is a cobbled together from bits of anesthesia equipment. And Penlon make about 2 of these a day. And we needed to build up to 400 a day off the back of the demand. So we had to set up parallel supply chains and scared ourselves witless by the fragility of UK supply chains. I mean, you look around us now, we've been scared witless by supply chain problems in October 21, but back then it was exacerbated by the fact that planes weren't flying. I mean, everything stopped. So where we couldn't source parts effectively, we decided to vertically integrate and make stuff from scratch, including reverse engineering a lot of stuff that didn't have any design information. And that's where the Formula One teams, particularly with valves and fittings and all that sort of thing, were brilliant at shelling these things out from their NC machining kit. We did come across, though, some major supply issues, which is it's an important kind of tale for how industry deals with its suppliers. One was a critical flow valve, which is basically in every intensive care ventilator in the world, and they come from a company in Switzerland they're a single source of this very complex valve, which we deemed would take too long to reverse engineer and manufacture ourselves. So we had to get the parts. You can imagine a global demand for ventilators. This company was just overwhelmed with demand. And the first conversation, even including some government muscle behind it, was where do you want to be in the queue, because you're a long way back. So rather than be defeated by that, the team from McLaren volunteered to go in across to Switzerland to see how they could possibly help de-bottleneck this manufacturing facility. And in building a relationship with the supplier, they realized that the key bottleneck was in some quite complex assembly fixturing, which, if that could be duplicated, would create a much greater yield from the company. So McLaren went in, looked at it, agreed it, and then went away and made a complete duplicate set of assembly fixturing in a week, and had it back out with them in parallel process. And that de-bottlenecked the whole thing. And no surprise, we got to the front of the queue in terms of supply of this critical component. And I think there's a really important message there. I was brought up in the car industry, and the norm was to be really tough and beat up your suppliers. But here, by working with the supplier, we ended up with the right parts at the right time in the right place in the queue. So for me, a real kind of lasting message there. The other critical thing is that there's a bunch of electronics in this, and most of the parts we could get with the help of Arrow, and I know the guys are down at the far end of this auditorium here today. There was a microprocessor, an AMD chip on there, and Penlon had been happily using this chip because they had an all-time buy of the chip. They had 200 or 300 of them, which was fine for them for years. We needed thousands of them, and it had gone out of production 12 years ago. So engineers, right, well, where's it used? Washing machines, video cassette recorders, sort of rushing around seeing where we could possibly get this part. No chance. So we were faced with a real showstopper, a critical chipset, which we couldn't get a hold of. So again, working with our Formula One colleagues, who of course got access to a lot of electronics, we got the chip mask from AMD. We got them to relinquish it to us, and we booked fabrication space in a chip facility in Israel, which cost us $6.8 million up front. Government took 24 hours to come up with the money. So when people diss the Cabinet Office for not responding, they came up with the money in 24 hours. And we booked it, got the chip set, mask, and had the chip made. And it did not hold up production one iota. So an amazing piece of smart work, engineering work with the supplier to get a critical bottleneck undone. The other critical thing for this device, because it's a medical device, it needs regulatory approval. Not only regulatory approval for the device itself, but for the manufacturing facilities as well. And there's good reason for that, because you don't want to just start shelling stuff out that's unsafe. You know, this has got complex airways in it. Somebody could be breathing the contents of these machines for several weeks. So there's very high standards relating to that. And it normally takes about 9 months to get regulatory approval for a new device. We didn't have 9 months. So again, working with the regulator, albeit under the pressure of a crisis, the team at Penlon, coupled with the help of Siemens and working with the MHRA, the regulator, got it approved, including clinical trials at Southampton. So this is having people plugged into the device. Got it done in 3 weeks. So a 9-month program was compressed into 3 weeks. Here's a kind of little cartoon of how we set everything up. Top left-hand corner is us shaking hands with the Cabinet Office. Although the money didn't flow immediately, it did in the end. So we then set up parallel supply chains. So coupled with the work we were doing with Smiths, we procured over 11 million parts in the first 4 weeks. We got DHL set up to do all the logistics and inspection. We set the Formula One teams up to make a load of parts so we could be in control of the supply chain. So McLaren, in the first 5 weeks, made over 70,000 components in their Formula One machine shop, and then went on to do several 100,000 all up. What was really encouraging for me is the response of UK SMEs, a flood of people with spare capacity. It was so heartwarming to see so much capability in the UK being offered up. And one lasting impression I have of it all is, we get dissed in the press a lot in manufacturing and engineering about, we don't make anything anymore. Well, the talent of the UK in its ability to do stuff and make stuff was quite extraordinary, and brought really into focus through this exercise. We needed, of course, to build this thing, so we set up parallel factories. We set up a factory in Airbus in Broughton, a big piece of space which was designated for the development of their next generation wing. Brand new factory, nice resin floor. We said we'll have that, and we modeled the factory. So the factory was done in a full virtual environment, both the layout and the process. That was done over a weekend with the help of Siemens, and within 3 weeks we'd built the factory out, and we had 550 people operating on 5 shifts at Broughton, putting the absorber and airflow meter together at Broughton. At Dagenham, with the help of our friends from Ford, they cleared a warehouse, and we set a factory up there, and that took just 4 weeks to put together, and we had 700 people on 3 shifts putting the ventilator system together. Bearing in mind this was all in the lockdown, the motorways were empty. I remember going out to see some of these facilities and being spooked out on the M40 where I couldn't see a car in either direction. So everything had stopped at this point. And we were faced with the challenge of training hundreds of people in a COVID-safe way. And a normal way would be to bring all of these people to Penlon to see how these things go together, but we couldn't run the risk of a mass contamination event. So we used some really cool technology that we've been developing with Microsoft in the high-value manufacturing catapult. So the use of Microsoft HoloLens, so these VR and augmented reality headsets, so we could bring the entire assembly operations of Penlon out to hundreds of people working remotely. So a lot of the training was done in a virtual reality environment, so people could see at both Broughton and at Dagenham exactly what was going on, how to put it together, the kind of nips and tucks and wrinkles of this fairly cottage-based industry approach to putting this device together. So a really powerful use of VR and AR tools in an emergency. So from all of these sub-assemblies, we needed to put it on a trolley, and typical with McLaren, jumped at the chance of the thing with 4 wheels on it. So McLaren made the trolley, and they were producing sort of 250 of those a day out of Woking. And to see them all stacked up in their fantastic headquarters building at racks and racks of these trolleys was quite extraordinary. It was then finally assembled together in a place called STI in Hook, and then we repurposed the Penlon facility to be a final test centre. So Penlon were doing the final test, and it was all shipped off then to Donington and on to the NHS. Getting it done quickly did require a very different approach, and I think those of you familiar with engineering and manufacturing processes, the kind of classic pre-production phase, prototype, 2 phases of prototype, plan, do, check out all the problems, resolve them all, get into the next build, and then when you've resolved most of your problems, start the steady ramp up to production. But we couldn't afford to do that, so we were developing the product as we were setting up the manufacturing facility. So we'd actually started building what you call off tools while we're still resolving a load of engineering problems. The only way we could do that, to be honest, which is a fairly high-risk thing to do, was throw a lot of resource at it and have an utterly uncompromising approach to problem resolution. So this, this early stages of getting on with it and ramping everything up in parallel, critical success factors, lots of resource, very focused on constraint management, some very simple change management and control processes, and I'll come on to it in a few minutes, open data, one version of the truth throughout. The pace, unbelievable pace. In the early stages, the team, we were operating at probably working 18 to 20 hours a day at the beginning to get through establishing what we were up against and start getting all the processes established. But 4 weeks after accepting the challenge, we had the first unit in production, and through that plan, do, check, act, the first 100 units took us a really painful 29 days to make. But you can see from the rest of the graph, it then accelerated exponentially, and at the end of 12 weeks of build, we were building at a rate of 400 a day. So the thing was running like an absolute sewing machine at that point. And that was like 200 times the rate at which Penlon were building their anaesthesia equipment. Real success factor for me, was how this thing was managed. Bearing in mind we're bringing very different cultures together, aerospace, automotive, Formula One, how to bring that all together in a cohesive force. Relatively simple actually, because we all spoke a common language, which was engineering. All of the core people in the core management team, all engineers, all experienced in complicated program management. And we all found, although we used different three-letter acronyms for things, the product development process, whether it's a motorsport, automotive, aerospace or medical device, pretty much the same process. We had no time to set a culture. Typically you'd have a sort of town hall event and say, these are our values and behaviours. Didn't have any of that. There was only one rule right at the beginning, is no egos. So bearing in mind we were bringing some big players together, we had the chairman of Ford of Britain in the core team. We had real big companies, the Formula One guys, no space for any egos at all. We've got a job to do and we're going to drop all of that stuff. We can't afford to pull rank on each other. Our only mission is to deliver. So it created a culture purely about delivery, very, very output focused. We chose the best individual to do a specific job regardless of rank. So we had relatively junior engineers rubbing shoulders with their chairman at Ford on the same level, purely valued for their contribution and their ability to get the job done. And we empowered them to do what they needed to do financially, technically, and it's the only way we could do it, is to unleash the whole potential of this talent pool we had. And it was absolutely exhilarating to work in it, because the pace of achievement by empowering people and stripping away the bureaucratic nonsense that we all live with every day was enormously empowering, and the pace with which we got things done was quite remarkable. It meant, particularly with the no egos thing, is a complete no blame culture. So if something went wrong and it was beyond the ability of an engineer or a small team to fix it, it immediately became a team problem, and we throw everything at getting the problem fixed. And again, a remarkably exhilarating environment to work in when you can tackle problems collectively and put the focus on it. We had regular drumbeat sessions. The meetings that we had, we were forced, really, most of them only about 15 minutes long, just to synchronize. We had one source of the truth. So open data, we could only operate because we had multiple company systems, so we did like a pop-up IT system. So we had materials management, pop-up IT, problem resolution management, pop-up IT, and we all committed to these platforms. A lot of people talk about the power of open data. Not many people actually rise up to the challenge of embracing it. But here we had to do it because it was the only way we could communicate. And I can't begin to tell you how powerful that was in communication, so that anybody acting anywhere across the network that we had was accessing the same information. There was no filtering, There weren't reports collated, aka managing the truth. We just stripped the data straight out of the data set and looked at it raw. It helped by having some pretty cool tools. So our friends at Quick Release and Newton helped us visualize a lot of this data. So we had something called the worm chart, which is up there, which aggregated all the supply chain and production system data to show our build projections. And we showed the parts at the slowest pace in the system displayed on the chart. So it was our theoretical build capacity rate, and anything that dropped below the line was a trigger point, and we could drop straight on and interrogate it and do something about it. The speed chart, we modeled all of the processes across all the sites, and then daily we did a check on where the rate was for those specific processes. So as we looked at the constraints, we put SWAT teams on to overcome the constraints and lifted the pace of the production facility all the time. So basically, it's almost like a sort of fleet of gazelles across the Serengeti. We were chasing the slowest gazelle to get it up to the front. And by doing that, we lifted the capacity right up. So that was absolutely instrumental in achieving this 400 a day build rate. The supply, we thought the killer issue would be parts. We never stopped for parts. It was quite extraordinary. But we had a beautiful visualization tool called the Blue Wave. So daily, well, this is real time. Dark blue was parts line side. Light blue was stuff in DHL ready to go. Orange was, in pipeline, and red was we ain't got them, but we need to focus on them. So really interesting seeing that flow and keeping that bow wave of blue ahead of the build curve. And then an absolutely unrelenting approach to problem resolution. Again, taking huge risks with a program like this. The principal way we mitigated those risks was having a lot of talent focusing on issues management. An absolutely uncompromising approach. So there you have it. In that 12 weeks we built 11,683 ventilators and fulfilled the government's order. They did order another 15,000 of them in the height of the panic, and then realized they didn't want them. I said, well, guys, you can't stop, we've bought the bits. And in fact, we then to close the project off neatly, we managed to find a home for the 15,000 sets of parts and gave the government back 10 million quid off the back of that. And you might think that in this headlong pursuit of delivering this stuff, that we would have left a trail of financial carnage behind us with a huge bill to pick up. We pulled a business case together to sell to the Cabinet Office to say, we think we can do it. And we said, this is basically, it took us about 12 hours to pull the business case together. We reckoned it was going to take us something in the region of 120 million quid for the bits, for the facilities, and our time, which is all just charged at cost. There was no margin in that. And we did deliver it for 120 million quid, which meant that each ventilator was something just shy of £10,000 a ventilator, and it'll cost you 18 grand to buy an intensive care ventilator on the open market today. So those people that think that this was just a throw money at it out of control, it wasn't the case at all. It was a fine example of exercising the same degree of control of the numbers as of the engineering, and also the fact that we never paid a ransom for parts. Because if somebody said, right, well, yeah, you can have some parts, but they're 50 times more than the normal market, we just say, no, we'll make it ourselves then. Or in the case of the valve from Switzerland, we'll help you overcome your bottleneck. So this very intimate relationship with suppliers, big message to the audience here, that actually got us on target and at the lowest possible cost. So just shows the power of actually working with your suppliers rather than constantly beating them up and taking all their margin off them. So really, really important for me. Just final slide, the key success factors for me and the team. It really helped having a compelling purpose. This was kind of like Spitfires in the war. We need to make some and we need to make them fast. People were dying. It doesn't half focus the mind. A team, best possible people to do a given job, selected purely for merit and fully empowered to get on and do what they needed to do. Incredibly energizing, a very high degree of trust amongst us, often made us think, well, why can't we work like this all the time, actually? A willingness to take a personal and corporate risk. We didn't know initially we were going to get paid for it, so there was no time to mess about with people whinging about order cover or anything like that. We just got on with the job. The open data, critically important, no hiding place. It added to the whole truth and honesty piece. We even shared our data real time with the customer so they could see exactly what was going on. Uncompromising constraint removal, just relentless. And in fact, seems like a huge challenge to tackle all of this stuff, but when you start breaking barriers down, it's energizing. It was kind of self-fueling and self-perpetuating. A will-do culture. It went beyond can-do, a real sort of stop at nothing. What was really interesting for me is that we had this culture in the management team, and we never actually made any conscious effort, because we didn't have the time, to communicate that out to the enterprise. So we ended up with about 3,000 or 4,000 people working on this throughout the entire enterprise, and going to see people at the extremities of the enterprise. So I went to see some engineers working on some process challenges at Airbus in Broughton in North Wales. Never met them before, and yet they were behaving exactly the same way as we were in the management team. We'd never actually communicated that to them. It was quite extraordinary how that culture had spread organically throughout the entire enterprise. Simple, transparent relationship with the customer. It did take us a while to build that relationship with the Cabinet Office, and they were giving us a lot of money on trust. It took a while to build that trust, but once we had it, great relationship with them. Tough customer, I have to say, but good thing they were looking after the public purse. And finally, strong relationships. No doubt, existing relationships, people I could trust, got the thing started, but we developed some really strong relationships en route. And I described those supplier relationships as being quite typical about the depth with which we went to deliver the mission. So there you go. Extraordinary series of events, and something I think I know it's been reasonably well reported, but a fantastic example of what Britain's actually capable of. A lot of other countries tried to do this because they faced a similar crisis, but only the Brits managed to pull it off, and that's something to do with, I think, the British spirit of collaboration and very much our sort of can-do spirit. So there you have it. I've got maybe five minutes or so if anybody wants to ask me any questions, but a great thing for us to have done, and those involved really quite a life-changing experience. Thank you.
Are there any questions? Anyone?
Excellent presentation. I was just wondering what was left behind in terms of standards, regulation, health and safety, quality, etc. Was that everything covered?
Yeah, we did. Yeah, because we couldn't sell the device without the medical regulator, and the medical regulator insisted, or had to, approve the facility. So, you couldn't have pigeons flying around in an old warehouse when you're assembling a medical device. So there was very strict standards. And bearing in mind the list of companies involved, they weren't going to suspend their basic health and safety standards. So all of that was maintained, just came with the turf. So I can't think, other than take huge risks technically, we didn't take any risks with quality or.
And the bottom line was covered as well.
It was, yeah. So I said it got delivered for
great story.
£120 million. So just goes, if you do some things quickly, you can't spend too much money.
Thank you very much for a very interesting talk. Do you have the names and telephone numbers of your A-team, and are you ready for when you next need to do it?
Yeah, I certainly do. And in fact, it has been asked, what are you going to do next? And a lot of us are actually advising government on big projects. So I'm tied up with at least 2 government-related projects to try to apply some of that learning. You'll never create the same sense of emergency, but some of that learning about the relationships with suppliers, the can-do culture, empowerment. Because when you look at a lot of these things, we put so many things in the way of the minimum viable stuff needed to deliver. You've got governance issues, you've got authority levels, all of which are in place for rational reasons, but they slow things up. I work company I work for, we've got authority levels to stop people spending too much money. Well, but then you disempower people and say, well, I can't get anything done here. So if you can go some way to release that, you can make a big difference. And so those of us who experience that say, we're really difficult people to work with now.